Hi, welcome to today's video. The essential learning target today is how to figure out the volume of a cone. Yesterday we talked about volume, if you saw that video, and we said volume equals the area of the base times the height. Today we have a cone. So a cone is a little bit different than a cylinder. The cylinder yesterday was going to be, we used that can, it kind of looked like this. It had a top and a bottom. A cone is more like a funnel. So we're looking at something where um, you have a point on one end and an open area on the other end. It would be an example of this, and also has a point at the bottom or top, depending on how you do it. So if you look at this board, volume of a cone has two parts. We got the height, which is going to be from the exact top to the center at the bottom, and it would make a right angle if you went to the other end, which would be a radius, obviously. And we have the area of the base. So the area of the base, we have to use a couple of math things with pi to figure out, but after we do it, it shouldn't be that difficult. Today's big formula, where it becomes a little bit different, is a cylinder would be continued all the way up to the top. A cone comes to a point, so it's not going to be the same. It's actually going to be 1/3 of a cylinder. So that's why our formula for volume of a cone equals 1/3 times base times height. So that's going to be our starting formula today as we go through. By the end of this, we'll be able to do a couple different versions, and you'll have a chance to practice two different problems and see if you can figure them out on your own before you get to extra practice. So let's start out with our first one. I want to give these some numbers here so we can try them out. So instead of just having this cone here where there are no numbers, we can't figure anything out, let's say that this height is going to be 6 meters. That'd be a pretty big cone. And let's say that we have the radius down here, or the bottom part of the base is going to be 2. So how can we use our formula to figure this out? Well, the first thing we're going to do is we're going to set up our formula. So we have volume equals 1/3 base times height. So let's plug in some stuff. Now, if you have a piece of paper, pencil, this is where you should be writing stuff down so you can get your practice in. So I would set it up always writing my formula first. So I have volume equals 1/3 area of base times height. So what do we know? Well, we know for sure that if we are going to get this bottom part, we are going to have to use pi times radius squared, and then we need our 6 for our height. So we're going to start plugging in everything we know. So the volume equals 1/3, that didn't change anything. The base we are going to set up is pi r squared. So pi goes right here. R, the radius, is going to be 2. I'm going to stick a 2 in there, and we're going to square it. So I'm going to put a little 2 up like that. Now, to make it a little less confusing, a lot of times what we'll do is we'll put a 2 or a parenthesis around the 2. That way we know that there's going to be a 2 there, and that's our interesting number. Now we stick our height. We're going to multiply that as well, so let's do a parenthesis height. So now let's dissect this and start working it out. If we have this situation, we are going to have to do some math here. First thing that I would do is I would just basically start calculating it. So if you have a calculator, we can go through. Now here's the key though. When you start with your calculator, do this 2 first. 2 squared. So 2 squared, you're probably thinking, okay, I know 2 squared, it's 4. Then go 4 times 6, so we got 24. And then we're going to go 24 pi. And if we go 24 pi, we end up with 24 pi. But we need 1/3 of 24 pi. So 1/3 of 24. So if you think about it, if you have 24 as a whole, if you cut it up into thirds, what would one of those thirds be? Well, one of those thirds would be 8, because we have 8 plus 8 plus 8 equals 24, so we'd have 8. So after we do all that math, we get 8 pi, which is pretty awesome when you think about it. We can break that all down without having to do a ton of extra work. I didn't use a calculator, I just solved it. Now, if you have a calculator, you can use it, that's fine. But as we go through, now we have to do one more part. Remember, we want to figure out what it is about. So 8 pi is about, this is where I would use my calculator, 3.14 times 8, and that will give you approximately 25.1, remember it's meters, right? Meters cubed, or cubic meters. Because we're filling it in, it's cubic. Remember, if it's perimeter, it's just regular area, or regular distance. If it's area, you're going to have it squared, and if it's volume, you're going to have it cubed. So this would be the first example. Looks just like this one we're going to do in a little bit. So remember this part, come back to your notes if you need to, and you'll be good to go. Now there's one more that's a little bit tricky. It's not that difficult. But they just set it up differently. They put it into a sideways version. Let me put that one up here. We'll do one more together, and then see if you can do them on your own. All right, so I'm not the best at drawing these, but I'll do my best at this one. So this is going to be a sideways cone, and it's going to go like that. Now we're going to give it some labels here. So we're going to put our center right there. Our radius is going to be 9. Remember, we're going to go radius squared, so that's going to be important later on. And our height is going to be right here. But here's the tricky part. They're not going to give us the height. It's going to be like a backwards problem. But they are going to give us the volume. So the volume on this, they say, is going to equal 956 feet cubed. Now you're thinking, okay, well, that's weird. Last time you gave me all the numbers I needed. I could multiply. Everything was good. What's going on here? Well, same thing. We're just going to set it up, but now we have some different things. Let's set up our formula the same way that we would. I think I should have enough space over here, but I'll try to see if it'll fall fit. So remember our formula for cone. We got volume equals 1/3 area base times height. So what do we know? Well, we know for sure the volume because it's right here. So we got 956. So I'm going to put in 956 instead of V. I just substitute. Now I'm going to keep my 1/3 because I know that's okay. Do I know the base? Well, I kind of know the base. I know that I have 9 for a radius, but that's not the whole base. The whole base would actually be pi r squared. So I have to go pi times r, the radius, which is 9. And I'm going to square that. So that's going to be exciting. And I don't know my height. So I can just leave this as h. So I know a lot, but I don't know h. So when I start solving this, I'm going to have some different things to do. So what can I do? I can go 9 times 9, we get 81. I can go 81, like 1/3 of 81. So if I cut 81 into 3 parts, I can get that. I can go h, I can divide it. I have all kinds of things I can do. So when I start doing this, I'm going to end up with 27 pi. That's basically 1/3 of that. 81 into thirds is 27. So 27 pi times h still. I don't know h, so I'm going to leave that alone. And I still know my volume, but it hasn't changed. 956. Now what do I do if I want to get h all by itself? I got to divide whatever's next to it. So I have to divide both sides by 27 pi. So if I do that, if I divide both sides by 27 pi, I'm going to end up with doing some math here again. Probably got a calculator going on. If I go 27 times 3.14, then I divide, I should get about 11.3 feet for this height. So I'm going to draw another arrow just for fun, for that height. Now, if you think about it, would that make sense? If this is 9, could that be about 11? Yeah. If I would have got 113, I would have said, oh, that might be way, way too big. But in this case, it looks pretty good. There's a little bit of math going on here, so you do have to calculate. So don't be afraid if you start calculating and you get some weird numbers or things aren't working out perfect. It's going to take a little bit of practice. Let's do that right now. Let's take a little bit of practice. This one right here, let's try this one first. I'll erase this board. Well, actually, I'll leave it. And I'm just going to move this down a little bit. So what if I put this right here? We're going to try this one right now. So I got my cone. This is like the first example we did. I got my 6 centimeters, 15 centimeters. We're going to try to find the volume. So pause it right now. Try to figure it out and see what you get. All right, you're back from the pause. Let me tell you the answer. So the answer to the on your own, number 1, is going to be 180 pi is about 565.5 centimeters cubed for our thing there, for our volume. We got that figured out. Now, that one might be a little tricky, so let's try the second example. This is going to be another one of these where you're going to end up getting the volume, but not the height. So go ahead and pause this one. If you're not sure how to do it, refer back to the second problem. Try this one out. We have 15 for our radius. Our height is unknown, and our volume is 7,200 yards cubed. So go ahead and pause right now and try to figure it out. Okay, if you're back from that, let's take a look at the answer. The answer would be about 30.6 yards. So that would be pretty high there. My picture might not be perfect. All right, if you need more practice, you want to try a couple more, check out Big Ideas. I'll put a few practice problems on there, probably about 4 or 5 problems for you to try out, and we'll see if we can get this skill down so we can master it. Thanks a lot. We'll see you next time.